Hello student, this is Dhanjit and you are watching me on my YouTube channel Reaction Concept. Student, we have already discussed the vapor pressures of different solutions in the solution sector. Today we will discuss about different type of solutions, that is ideal solution and non-ideal solution. We'll discuss about ideal solutions and non-ideal solutions. In the class 11, I hope you have already studied about ideal gas and non-ideal gas. So what is ideal gas? The gases which obey the gas equation are known as ideal gas, and which are not obey the which does not obey the ideal condition, that is ideal gas equation, those gases are called as non-ideal gas. Okay, similar concept can be applied in this case also. In solution case, there is a law we have discussed, that is Raoult's law. Here Raoult's law is considered as a basis of this ideality of a solution. The solution which obey the Raoult's law at any concentrations are called as ideal solution, and which doesn't obey the Raoult's law at concentrations, any concentration, any temperature, are called as non-ideal solution. Okay, so if we now let us see the ideal solution. So what would be the definition? These solutions that obey the Raoult's law at any concentration at temperature condition are called as Raoult's law. So let us see the pressures and pressures value of this ideal solution. In this case, for ideal and non-ideal solution, we will take liquid solution. Now consider a liquid solution. Let us consider solution of liquid A, which is in pure state. Liquid A, this is in pure state, and liquid B. When these two are mixed, we will get a mixture of A and B. Now we will have to characterize the mixture A plus B, whether it is ideal or non-ideal. Okay, if it is ideal, what will be its pressure character? Those things have to be here characterized. These are the pressure value. Okay, these things I already discussed. This is the mixture. So from Raoult's law, what we have got? In the mixture, the PA is given by PA naught into XA, whereas PB is given as PB naught XA, and total vapor pressure of the mixture is given by PA plus PB. Okay, these things I have discussed in the previous class. Now if we do an experiment and measure these three terms, PA, PB and PT, this is total pressures, then suppose these values are from experiment Suppose we have get PA experimental, then PB experimental, and PT experimental values. These are the experimental values for the mixture. If these values are equal to the theoretical value of Raoult's law, then the solution will be said as the ideal solution. This is what saying in the definition. So what we have considered, if PA experimental of the solution, that is whatever the value we have got from the experiment, that should be equal to the theoretical value. Okay, which theory? Raoult's law. This should be equal to the PA, and PB experimental should be equal to the PB, whereas total pressure of experimental should be equal to the total pressure of the Raoult's law. If these three conditions are satisfied by a solution, then that solution is said to be an ideal solution. Okay, now we'll see the different characteristics of ideal solution. First one, intermolecular force of attraction. Intermolecular force of attraction. Again, you consider the solution diagram where you have a liquid, pure liquid A and pure liquid B, and mixing of both these will give you the mixture A plus B. This is A, this is B. Okay, this is liquid and this is liquid B, and this is mixture. You see, in this case there are molecules of A, and in the pure liquid there are molecules of B. So in the pure solvent of A and B, there will be interactions between AA and BB. What are the interactions in pure state of the solvent? AA and BB interactions. AA interactions and BB interactions. In case of mixture, there are molecules of AA and BB. So interaction between the molecules R becomes A and B. In case of ideal gas, this AA interaction, that is solute-solute interaction and solvent-solvent interactions, are equal to the solute-solvent interaction. That is, in case of ideal solution, AA interaction and BB interaction AA interactions and BB interactions, these two interactions are equal to the AB interaction. This is equal to okay. In case of ideal solution, the AA interaction and BB interactions are AB interaction, equal to the AB interaction. Now we'll see the volume of mixtures. Del V mixtures. The change in volume
on mixing. Okay, del V mix can be written as total volume after mixing and volume of A plus volume of B. Okay, since both the interactions AA and BB interactions, AA and BB are equal to the AB interactions, therefore the distance between the molecules between AA and BB are equal to the distance between the molecules AA and BB. So therefore space occupied by in the mixtures are equal to the space occupied in the pure solvent state. Okay. So in both the cases volume occupied by the substance A and B are equal. So in this case Vt would be Va plus Vb. Okay, the final volume and the initial volume of these two solutions are equal. So we can write in this case del V mix would be equal to 0. Now let us see the change in enthalpy during this mixing, that is del H mix. This is the change in enthalpy. In pure liquid A, there are interactions between AA molecule, and pure liquid B, there are interactions between BB molecule. Therefore, if we mix these two and made a mixture, there would be interactions between AB. Therefore, on mixing, these interactions between AA and BB should be break down. So, breaking of these two bonds or interaction needs some external energy, and these are called as enthalpy. Okay, these are enthalpy. So in this case heat is absorbed, heat energy is absorbed, because in this case AA interaction and BB interactions are breaking, whereas in this case heat is absorbed. Whereas in case of mixture, you see interactions between A and B molecules are formed, and forming of interaction will release energy from this system. It will release heat. Okay, on formation of AB interaction there will be a release of heat. Since these interactions are equal, therefore heat absorbed should be equal to the heat released. Okay, therefore del V mixed, that is change in enthalpy on mixing, would be 0, because heat released equal to the heat absorbed in this process. Okay, both these heat energies are equal, therefore del V mix is equal to the 0. And other character is del G. This is the change in Gibbs free energy, and del S mix. Okay, this is the entropy change during this mixing. This value, since mixing is spontaneous, therefore this would be less than 0. Since on mixing number of molecules is increased, therefore entropy also increases, because increase in number of molecules will increases the randomness of the system. Therefore del S mix for this solution would also going to be a positive value. These are the characteristics of ideal solution. Well, if you see the graph of vapor pressure versus the mole fraction of the component, then it will be look like the graph of Raoult's law. Okay, so for ideal solution, the graph of
So this is the graph of ideal solution, which is exactly same to the graph of Raoult's law. Okay, because ideal solution follow the Raoult's law. Okay, now we'll see the non-ideal solution. What is non-ideal solution? Non-ideal solutions are those solutions which doesn't obey the Raoult's law. So non-ideal solution does not obey the Raoult's law. In non-ideal solution, whatever the pressure value, vapor pressure values we have got from experimental values, okay, these are experimental values of pressure of A, pressure of B and total vapor pressure. Okay, these experimental values are not equal to the pressure that we got from the Raoult's law, that is theoretical value of A, theoretical pressure value of B and total vapor pressure. Okay, theoretical means whatever we got from Raoult's law. Okay, these values are known as, we called as theoretical value. So why it is happened? So this is because of the interactions between this solute-solute and solvent-solvent and solute-solvent interaction. Because of those interactions, it happens in case of non-ideal solution. We'll see that things in later on. Now you see characteristics of non-ideal solution. First character is that whatever the interaction, AA interaction and BB interactions, these interactions are not equal to the AB interactions. In case of non-ideal solution. Okay, that is, here it is the solute and solute, solute and solute, solvent and solvent. Here it is solute and solvent interaction. These interactions are not same, and because of this interaction, difference in the interaction between these two, the del V mix, that is change in the volume during this mixing, would not be equal to 0. And the change in the enthalpy during this mixing, which it also not equal to 0. Okay, these are the characteristics of non-ideal solution. There is another characteristic, that is del G and del S. Okay, these two values are same with the ideal solutions, because Gibbs free energy will be negative and change in entropy would also be positive here. Okay, these are same as ideal solution. Since the process is a spontaneous process, the change in Gibbs free energy would be negative. Since the number of molecules or particles during the mixing is increased, therefore the randomness of the system is also increases, because of which the change in the entropy of the system is also increases, which gives you a positive value, that is del S of the mixing would be greater than 0. So these are the characteristics for a non-ideal solution. Now these non-ideal solutions are divided into two types, okay, depending upon their deviations from the Raoult's law. One is called non-ideal solution showing positive deviation, non-ideal solution showing positive deviation, and other one is called non-ideal solution showing negative deviation. Okay, now we'll discuss about these two type of non-ideal solution. Let us first consider the non-ideal solution. In this case, the non-ideal solution will show some positive deviation, means the pressure value, whatever we got from the experimental value,
These are the experimental values for vapor pressure of A, B and total vapor pressure. These experimental values will show some positive deviation, means these values are greater than the values that we expected from theoretical value, that is Raoult's law. These are greater than the Raoult's law value. Okay, in this case, a solution, a non-ideal solution will be called as a non-ideal solution having a positive deviation. So graph will be the graph of vapor pressure versus mole fraction. So this graph will be somewhat like, I am showing the graph. Now see, here it is showing, given that these pressure value are greater than the theoretical. These are the theoretical graph. Okay, so the observed value will be greater than these values. So the pressure value whatever we got for the A component would be greater than this graph. So graph will be like this. Okay, it will have pressure value greater than the theoretical value. Okay. So for B also, the value for pressure, vapor pressure is also greater than the vapor pressure of the theoretical value. In this case also, total pressure also have some greater value than the theoretical value. This would be the graph for non-ideal solution having positive deviations. Okay. Now we'll see why it is happening in case of non-ideal solution. The reason behind this phenomenon of positive deviation. Now we'll see the different characteristics of non-ideal solution showing positive deviation. First we will consider the force of interaction. Force of interactions between the molecules. In case of non-ideal solution showing positive deviation, the interactions between the solute molecule AA and solvent molecule ABB and the interaction between the solute and solvent, that is AB interaction, these interactions are weak interactions. Okay, here these interactions are greater than the AB interaction. Okay, that is solute and solvent interactions are here weaker. Since these are weaker, so it can easily be evaporated. Okay, it can easily be evaporated. So at a low temperature it will vaporize to a vaporous state, so it will produce high amount of vapor pressure. Okay, that is why the observed value of vapor pressure for such type of non-ideal solution is greater than the values that expected from Raoult's law. Again we will see the del V mix, that is the change in volume during this mixing. You see these interactions are weaker interaction. Okay, since these interactions are weaker, the distance covered by the molecules in the solution is greater than their respective pure solute. Okay, so since the distance is high, the volume occupied by these molecules in the solution will also be greater. So in this case, the del V mix, which is the volume occupied by AB and volume occupied by A and B. Since this is greater than this value, so it will give you a positive value. Okay, therefore del V mix for non-ideal solution giving positive deviation will be greater than 0. If we discuss the enthalpy change for such mixing, for such type of, it will also be come out as positive value. Why? You say in this case, when this bone, weaker bone is formed, the heat released in this process is less amount of heat will be released, okay, compared to the heat required to break these bones. So in this case heat absorbed is more. So del V mix, which is equal to the heat absorbed minus heat released. Since heat release value is less, therefore this subtraction will give you a positive value. So the del H mix for a non-ideal solution having positive deviation will give a value greater than 0. So if you check the value of del G and del H for non-ideal solution, del S, these are same as ideal solution. There is no difference in such values. Now we'll discuss non-ideal solution showing negative deviation. Non-ideal solution with negative deviation. So in this case, suppose you have a pure solution here also A, and it is mixed with pure B, and it is give you a mixture of A plus B. In this case, if you measure the vapor pressure of PA, PB and P total vapor pressure in the mixture by an experiment barometer, then you will find the experimental value of this vapor pressure. Okay. This value for a non-ideal solution having negative deviation will be less than the value that is expected from theoretical value. Theoretical value means whatever we got from Raoult's law. These are the values that we got from Raoult's law. Okay. In such case, a non-ideal solution is defined as a negative deviation having non-ideal solution. So in this case, what happens? You will see the force of interaction here. AA interaction and BB interaction and AB interaction. This AB interaction is stronger here. It is stronger than AA and BB interaction. That is why it is difficult to evaporate these molecules, because these interactions are stronger. It will not easily go to a vapor state. It doesn't go to the vapor state easily. Therefore, the pressure exerted by these molecules will be less. less pressure will be exerted. That is why the experimental value of vapor pressure of these molecules will be less than the value of vapor pressure that is expected from the theoretical value. Okay. Now let us see the del V mix in such case. In such case, since this is a stronger bond, it will close these two molecules. Okay, close proximity will be there. Therefore, the distance covered by this molecule also be less. As a whole, the volume occupied by these substances A and B also be less. So, del V mix will be negative. The enthalpy of change during this mixing. If we calculate, this heat released during this process will be more, therefore, compared to the heat absorbed in the breaking of these two bonds. Therefore, del H mix, which is given by heat absorbed minus heat released. In this case, heat release will be more because this bond is more stronger. Okay, formation of this bond will release some amount of heat, and that amount of heat will be more. Therefore, this value will also have some negative. Okay, so these are the characteristics of non-ideal solution having negative deviation. Now we'll see the vapor pressure versus mole fraction graph for such solution. Versus mole fraction graph for non-ideal solution having negative deviation. Okay, first you draw the graph of Raoult's solution for Raoult's law. This is like this one. Okay. Okay, so graph will be goes through the below this line. Okay, this vapor pressure value of observed experimental value will be less than the predicted value by the theoretical expert. So this would be the graph of vapor pressure versus mole fraction for a non-ideal solution having negative deviation. Okay, guys, I hope you have understand whatever the things I have discussed here. If you have any doubt, you can ask me in the comment section below, and if you like this video, then give a big thumbs up to this video and share this video with your friends. And if you are new to this channel, then subscribe our channel and don't forget to press the bell icon. Thank you.